during his time, there was a national award for this AICRP. And besides that, he is our Vice President of Indian Society of Agricultural Engineers. He is our team member of ISA. And with this, I invite Dr. Mehta, R Mehta, to make presentation. AgMechatronics, although we have defined it Agritronics in our first discussion. So we will discuss this Agritronics or AgMechatronics. Dr. Mehta, please.
Thank you, Dr. Indramani. Am I audible?
Yes,
yes, please go ahead.
So good evening, everyone. Professor Gajendra Singh, good morning, sir. My seniors, Dr. Pritam Chandra, Dr. K.N. Tiwari, and other seniors and friends. So today I am going to talk about the future of Indian agriculture, AgMechatronics. As Dr. Indramani mentioned that at the start of this webinar, it was told that Agritronics maybe. So I little bit deeper. So on that also I will make a presentation and discuss about those points. But first briefly I would like to tell about the Indian agriculture. So as we are talking that we have small land holding and our 86% of the farmers are below 2 hectares. Only 4% of our holding is above 4 hectares. So we can say that only 4% of our land holding is suitable for individual ownership of farm equipment. And that's why government of India is putting a lot of thrust on custom hiring of farm equipments. And for smart equipments, also there will be a scope mainly on custom hiring of custom hiring. Another is the labor availability in agriculture is reducing day by day. 55% of our workforce was engaged in agriculture in 2011, and it has gone down to around 42% right now. It is further expected to go down by 2050. And in that also the role of women will increase because male workers are migrating to urban area to work in other industry and other jobs. So women will be in the field. So that highlights need for development of equipment or machinery which reducing the drudgery will be gender neutral. Now I come to the AgMechatronics, because mechatronics means mechanics plus electronics. And in Indian agriculture, most of the time we are using agriculture machinery. So we have to add agriculture plus mechanics and then electronics, then it will be suitable for Indian agriculture, particularly related to machinery. So that's why I wanted to say that we can name it as AgMechatronics, or even in some of the countries it is also named as AgMechatronics also, because here we'll be having application of machines, and then when we use the electronics in machines, then it will become smart machinery, which will reduce the drudgery as well as which will help in enhancing the input use efficiency. Next. Most of the time we are talking about use of mechatronics in different fields, but nowadays we have started talking about in Indian agriculture also. So in my presentation, I may like to brief that we have started working in the area of precision farming in 2010, and Government of India through ICR has put a lot of emphasis on working on precision farm machinery during 12 plan, then after that SFC period, and presently also a lot of thrust is put on development of precision farm machinery. So Government of India also launched 2 projects related to precision farming under NAIP, National Agriculture Innovation Project. One project was led by our institute, and we started working on that project in 2012. Another project was led by PIU Ludhiana. So some of the technology which have been developed at PIU, it was just briefed by Dr. Manjeet Singh a few minutes back. Another, we are having presently one project on CRP, on farm mechanization and precision farming. So in next plan or plan which I just started this month, we are going to put a lot of focus on development of precision farm equipment in that consortia research platform, which is having centers in different parts of the country. In addition to that, we are also putting focus on development of precision farm machinery and AICRP on farm implements and machinery. So at our institute, as well as some ACRIP and CRP center, we have some of the equipments which we have developed related to precision farming. I am presenting in my presentation. I may not able to cover all the equipment, but a few of them are presented. Presently, in the NASF project at our institute, we are working on development of automated soil sampler and nutrient analysis system. So we have developed the soil sampler using proximity sensor-based depth control system, and we have also conducted trials of that soil samplers by collecting soil samples up to depth of 25 centimeters. And in the next phase, we are planning to work on assessment of nutrient availability in the field in real time. Next.
Next slide, please.
So we have also developed the ground speed sensor-based variable rate seed cum fertilizer drills. In that way, generally seed cum fertilizer drills are operated by ground wheel. So in that we have controlled the metering mechanism of seed cum fertilizer drill using PWM pulse width modulated motor, and it works on the basis of the forward speed of the tractor, so which was controlled, monitored by proximity sensors. So we have developed this 5-row seed cum fertilizer drill, and it varies the seed and fertilizer rate based on the variation in the speed of the tractor, and it also takes into consideration of skidding and slip in the field. Next. So at our institute, we have also developed the DSS-based automatic sprinkler system. So it works on the basis of the moisture availability in the field, and it was operated through telemetry system. And from using telemetry system remotely, it can be operated as well as monitored. Presently, we are working on IoT-based smart irrigation system at our institute. Next. Our scientists are also working to study the water stress indices using spectral reflectance and thermal imaging. So in that, they have used the commercial thermal image analyzer, as well as they have also developed the thermal imager with Raspberry Pi and using the IR sensor, IGB camera, GPS module, and they have also evaluated that sensors for wheat crop at our institute. And in the future or next stage, we are planning to remotely operate irrigated system based on the thermal stresses of the crops in the field. Next. So we have also developed the automatic irrigation system for rice crop. So in that we have used the reed switch flow with magnet fitted in sensors tube for measurement of water depth, particularly for rice field. And we have used this water level sensor by operated with solar panel, and the signal was transmitted through RF module to the controller, and then controller operated the pumps remotely. In that we have first predefined water level boundings, like for surface irrigation 1 centimeter, 3 centimeter, 10 centimeter, and for subsurface water level 10 centimeter we have defined, and we can vary that. So on the basis of that particular, when water is at that level, the system triggers and it automatically starts the irrigation in the rice field. And this whole system costs around 10,000. So which can be easily applied by the farmers, because a few questions were also there that we need to develop some technologies which can easily be adopted by farmers. Next. We have also developed a spread meter at our institute. Dr. Manjeet Singh has also shown one spread meter, and presently most of the countries are using Minolta spread meter. Speed meter is suitable for knowing the chlorophyll content of the leaves, and Minolta speed meter cost around 1.5 lakh, and we have developed the light sensor based using the TSLR 235 sensor speed meter. Next, click it. So here we use the two LED having the wavelength of 653 nanometer and 931, and this speed meter cost only 2,000 rupees, and we also compared its performance of this speed meter with the speed meter which is being imported from Minolta and some country, and we have got the R square value of 99. And recently we have licensed this technology to one entrepreneurs, Delhi-based entrepreneurs, and he is going to multiply it, and soon this technology will be adopted by, particularly by KVKH in our country. Next.
Next, please.
So scientists who have developed speed meter is also attending this webinar. So we also developed the multilingual nitrogen fertilizer dose calculator at our institute. So in that calculator works on the basis of the NDVI value. There were a few presentations during last few days in that NDVI, what is NDVI value, it was explained. So on the basis of the NDVI value of the crop, the fertilizer recommendations we get next. So that information can be given to farmers, and they can vary the fertilizer rate, as well as we can use the variable rate fertilizer also for that purpose. We have also, next, we have also developed similar web-based application also. Next. So we have developed the variable rate urea applicator for top dressing, and here we have used handheld green seeker for development of this variable rate urea applicator, and this was operated by a 6 volt 4 ampere hour lead SMF battery, and it is having swept width of 4 meter. And on the way, we first studied the NDVI value at different stage of growth of the crop of rice and wheat, and on that and during real-time basis, we have developed the relation between NDVI and the fertilizer dose requirement for crop tracing, and then we developed this equipment which was able to do the real-time varying the fertilizer rate based on the NDVI value of the crop at that particular time. Next. Next. We have worked on GPS-based variable rate fertilizer applicator. So for that, we worked at IIT Kharagpur and CIAE Bhopal. At both the places, we worked simultaneously under AICRP on farm implements and machinery. And for that, we have first developed the map of the nutrient availability map of the field. So that we have developed the manually nutrient availability map. And then we have developed the variable rate applicator, so which varies the rate at different grid points based on the availability of nutrient at that particular point. So for that purpose, we have used different kinds of sensors like displacement sensors. We have used GPS for monitoring the location, and then we have developed the controller which was operated by PMW motor on that seed cum fertilizer drill. Next. My colleague Dr. Nachiket has yesterday presented that at our institute we have made an attempt to develop the image-based herbicide applicator system. In addition to that, we have also made an attempt to develop the color-based herbicide applicator system. We have got some success, but still there is need to work more on this area to make a successful technology which can be commercialized. Next.
Next slide, please.
Next slide. So we have at our institute, we have also developed the uniform rate spraying system, because whatever spraying system we have presently, they are fixed rate type. Whenever there is variation in speed, on that basis, the total application rate per unit hectare changes. So in this we have put the sensors, forward speed sensors, so which monitor the speed of the tractor, and on that basis the flow rate of the sprayer was regulated. So that's why this sprayer was able to do the uniform rate spraying. And at turning also we have put some sensors so that there is no spraying at when the sprayer turns at headlands. Next slide. At IIT Kharagpur Center, we developed the ultrasonic sensor-based fumigate spraying system. In fumigate, we do 8 to 10 sprayings for a crop, and there is lot of chemical application in the crop. So this is sprayer is ultrasonic sensor-based, so it identifies the object. So whenever there is tree, at that time only it does the spraying operations, and it helps in saving the chemicals by 45 to 50%. As compared to the uniform rate spraying with the use of sensors and sprayers. Next. Our center located at Bapatla also conducted the study on application of pesticides and biofertilizers with the use of drains for cotton and chili crop, and they have used tank capacity of 5 and 15 liter. So they have conducted a study on cotton crop, chili crop, and rice crop also they have conducted, and right now also they are working on that. And recently, as mentioned by Dr. Indramani, Government of India is going to finalize the guidelines for operation of drones, and number of institutes have already initiated activity for working on drones. And at our institute also we have initiated activities for working with drones. So that guidelines will also help everyone in application of drones, particularly for agriculture applications. Next. We have also used the commercially available yield monitor, and that we mounted on commercial combine, and then we have done the study for yield variation within a soybean plot at our institute, and we have also developed the yield map. So PAU, Dr. Manjeet Singh has explained about it in detail. How does it work? Next. So I have shown some of the technologies have been developed at our institute as well as some of our centers. So lot of opportunity for applications of AgMechatronics in Indian agriculture, because India is world leader in IT, and that is hub of those technology, as well as we are leader in remote sensing also. Another thing, we in tractors we are world leader, particularly from volume point of view, as well as in farm machinery also. Nowadays we are exporting number of agriculture machinery to developed countries as well as even to developed countries also. So that will be helping us in development of smart machinery, and that those cost-effective machinery can be adopted by farmers. Another, we have large network of NARS system, National Agriculture Research System. That is ICR-based institute like CIAE, IRI is also working in this field, and then we have SAU, and then under CRP also we have centers in different SAUs as well as IITs. Some IITs are also attached with this NAS system. So that will also help in working in that. Another, some of these technologies will be costly, so those may not be adopted, like application of drones for spraying or for identification of pests, etc. in fields. So such technology can be used on custom hiring basis, and the government of India is also putting lot of trust on that custom hiring of farm equipment. So in that, such technology can also be adopted on custom hiring basis by entrepreneurs. Another, in India right now, irrigation, 50% area is irrigated. So in micro irrigation also, if we apply the IoT, AI, etc., then we will be able to enhance the irrigation use efficiency of water, and that will help in bringing more area under the irrigation in our country. Another thing anything?
Yeah, go ahead, please.
Okay. Another thing, we have some limitations, particularly for working in these area, but we also some message in our about so the scientists, young scientists working in the area, they may also electronics and robotics there and their application in agriculture. Another thing that's for adoption of these technology, farmers will need support. And for that, government and private sectors should come forward and help them by providing subsidy or developing the equipment at such equipment at low cost. Another, all the precision farm technology may not be adopted in our country. Like for example, we have seen the robotics based apple harvesting which is being tried in USA. Such things may not be applied immediately in our country. In future, if we don't get the labor, at that time such technology may be adopted. Presently, we are putting lot of trust on working on these. Particularly, we have already initiated working on development of precision farm machinery for enhanced input use efficiency of seed, fertilizers, chemicals, water, and energy. I have shown some of the equipments in my presentation also. We have also initiated working on autonomous guidance and monitoring system. IIT Kharagpur has initiated such activity. Even PAU is also working in that. We, at our Nirjuli, Bharat Nirjuli Itanagar Center has developed the remote control power tiller also under AICRP on ergonomics and safety in agriculture. At PAU, they are working on autonomous rice transplanter also. Such technologies are available already in China and some countries. Another, we are putting a lot of trust on application use of drones, particularly in agriculture. So one area for that is spraying. Another is for monitoring the crop health. So for that, we are planning to use drones for identification of the disease, and then we will try to have the site-specific application of uh, chemicals using drones. So that is future area. Another, we have to work on real-time nutrient assessments, development of real-time nutrient assessment system. We have already initiated some of the activities. Some of our SAUs as well as ICR Institute like IRA and CIAE have initiated working with drones. But in our country, what I feel that we may be able to use working with particularly for the operations which are difficult to do or which are repetitive in nature, like harvesting of coconut, then harvesting of black peppers, which are not easy to carry out using the manual devices as well as some self-propelled devices. Another, some of the earlier speakers have also highlighted that there is need for mechanization of protected cultivation, and in that we are planning to work on AgriBot. Another, we are planning to, we have already initiated some activity at our institute like IoT-based control storage system for food grains, pulses, as well as tomato, onion, potato. So in that, we will be putting sensors in the storage structures, and it will give alarm when there is infestation of any pest or disease. So we have already initiated such activity, and that will help in reducing the food grain losses in storage. Another area in which number of institutes have already started working, that is application of AI and IoT in agriculture. So we are also putting a lot of emphasis on working on smart irrigation and fertigation system, particularly for field and horticulture crops.
Okay.
So this is all in brief about my presentation.
Thank you, Dr. R Mehta. Very informative about what the CIAE Bhopal is doing work, as well as your suggestions about future. I will take to one or couple of questions. I see immediately Dr. Narendra Shah. Can you ask your question? Quick question.
Yeah, Dr. Mehta, you know, of late in Maharashtra, for example, I have visited a couple of pomegranate farms, and if there is some sort of, you know, study can be established in terms of efficacy and cost benefit of this automated sprayer, I think it will really spread like viral. Many farmers are looking for such solutions.
Yeah.
So you need to quickly establish efficacy and the cost benefit for the farmers.
Actually, I have shown one photograph with the use of ultrasonic sprayer. So that sprayer has been tested at MPKV Rauri farm, and even some manufacturers around that Kopargaon has already taken initiative for licensing of that technology, and such equipments are expected to be produced in our country very soon.
Thank you.
Thank you.
I think electrostatic sprayer, when I recall somewhere in 88, I made the first electrostatic sprayer in here in Mumbai. Then I remember still Ganpati was a student from AIT who did the electrostatic sprayer, and he took it to Israel. Problem was the chemicals. Before we go back, we'll discuss everything in the next one. Next one, there is a question. I want to invite Rajiv Patel, an industry person, is here. So he will reply. For the question is from Mr. Patil, Dattaraya Patil, who says which sprayer is better, engine operated or battery operated for the farmers. Rajiv, can you please answer the question?
Yeah.
Yes. See, both battery sprayers as well as engine operated sprayers can be used. The only difference between the two is with the engine operated sprayers, the discharge is high volume, and in battery sprayer, the discharge is low volume. So these are the two basic differences. Again, with the battery sprayers, you can use maybe 2 nozzles, 3 nozzles, or maybe low discharge nozzles, that is around 450 cc, or even less than that also for spraying operations. And under high volume, that is engine operated sprayers, again there are different categories. One is ULV, which is engine operated, which is the engine capacity is around 35 cc, and that is completely low volume, around 100 to 300 microns is the output size, and which is widely used in India. And then comes high volume sprayer, which is again motorized knapsack sprayers, which can also be used, which is widely used in northern areas, mainly in wheat and other paddy operations. So these are the basic differences what people can use.
Thank you, Rajiv. There is another question from Gauri Pati Rao. What is the
particularly from SP, and recently SP has imported.
No. Can I finish next question? Yeah, we will come back to that afterwards. In the discussion, we'll come back. What is the method adopted for designing the robotic manipulator arm? This, I think, we will not take in this year because it's a bit technical, highly technical. You take it directly with them. So now you are telling something, Dr. R Mehta, please go ahead.
Yeah, actually Patel is from SP, and recently they have imported one sensor-based sprayer, and they were about to evaluate it at their farm.
Yes.
During lockdown, I'm not sure whether have you evaluated it?
Yeah.
And
no,
they are also planning to introduce such technology in India. Another, you have raised question regarding battery-based or
it is not a no, Dr. C.R. Mehta, there is not a question from them. Somebody else's question, he answered it. Okay, thank you. Any other question you have? Any other question anybody has? I think questions are over. So thank you very much, Dr. C.R. Mehta. I think Indramani you can thank, and then I will take it over for the discussion next.
Thank you, Dr. Mehta. Actually, what we were expecting that, can you share what is going on in the CRP on precision agriculture? Little bit light if you can throw.
Yes, some of the equipment which I shown, particularly related to precision farming, are also developed in CRP. In CRP, during last 3 years, we have also developed other farm machinery in addition to precision farm equipment, as well as there is training component also. But now our ICR has suggested that during this plan, which has started from April of this month, our focus will be mainly on development of precision farm equipment under the CRP on precision farming. Farm machinery component will be removed from that, and that component will be further strengthened in the ICRP on farm implementation machinery.
Okay. Thank you very much. Thank you very much. Dr. Syed, please.
Yeah, I think we come to the third part, which is we want to basically 2 parts we have to do. One is to get your response for the training session, and the second one is a discussion on different applications. different applications which is useful. Now, before that, in short, I want to tell a little bit of how conducting about 10 days the program. I'd like to introduce the team of youngsters who are behind this for a few minutes. So I'd like to call on Mr. Setu. Can you come and tell a few words?